Welcome to Physics Trek. I'm Alan J, here with another work solution to help you improve your physics and to show you best practice in answering questions. So let's get started. In this question, we will be looking more closely at the motion of an object described by a distance-time curve. The gradient at a point is the clue to understanding this. It is simply a measure of the object's velocity. Here is our question. Question 3. The velocity time graph is for a car travelling along a straight road. Describe the motion of the car over each section of the graph. Before we delve into this, I think just a few words on gradient won't go amiss. Look at the gradient of a straight line. We have vertical and horizontal components in red and green. For an XY graph, these are called the y-step and the x-step. The gradient is simply the ratio of the y-step to the x-step. Gradient equals y-step divided by x-step. To find the gradient at a point on a curve, we put a tangent to the curve going through the point. Now in a distance time graph, the vertical component, call it delta d, is a distance, while the horizontal component, call it delta t, is a period of time. So knowing that velocity equals distance divided by time, you can see how the gradient is the velocity. Velocity is delta d divided by delta t. So it follows that in a region of the curve where the gradient increases, there's acceleration. Where it decreases, there's deceleration or retardation. And where the gradient stays the same, we have a constant or uniform velocity. Let's look at our question again. Here are the regions to describe: AB, B.C., C.D., D.E. and E.F. Let's start with AB. Well, the gradient here is increasing, therefore we have acceleration. Look at B.C. The gradient stays the same, therefore we have uniform velocity. C.D. The gradient is decreasing, therefore deceleration or retardation is taking place. D.E. The gradient is zero, so the velocity is zero. The car is static or parked. Now E.F. This one might make you think a little harder. Here the gradient is negative, and there is a decrease in the distance moved. In other words, the car is moving backwards and accelerating in that direction. So here is our written answer. Gradient increasing but negative. Car is accelerating backwards. And now a summary. AB, gradient increasing, therefore acceleration. BC, gradient stays the same, therefore uniform velocity. CD, gradient decreasing, therefore deceleration or retardation. DE, gradient is zero, velocity is zero. The car is static or parked. EF, gradient is increasing but negative. This means that the car is accelerating backwards. In other words, it's going faster and faster in reverse gear. And that's all for now. I hope this video has helped you out. There will be other worked solutions on the topic speed and velocity coming soon. Anyway, thank you all for watching, and please subscribe to the channel to be the first to see all the latest releases.